Good morning to all of you. Myself, Professor N.V. Adpe from SND College of Engineering and Research Center, Yeola, working as an assistant professor in SND in Electrical Engineering Department. Now, in previous lecture or previous video, we started the new topic, that is strain gauge. So also we see the Poisson's ratio. So we take a one problem on the Poisson's ratio. Uh, the problem is a resistance wire strain gauge uses a soft iron wire of small diameter. The gauge factor is plus 4.2. Neglecting the piezo-resistive effect, calculate the Poisson's ratio. Means in that the only given is gauge factor is plus 4.2 and calculate the Poisson's ratio. The gauge factor is 1 plus 2V plus delta rho by rho upon E. By neglecting the piezo-resistive effect, then the gauge factor is 1 plus 2V. 1 plus 2V. The gauge factor is known, that is 4.2. Then the Poisson's ratio, which is denoted by the V, and the V is calculated by gauge factor minus 1 upon 2. The gauge factor is 4.2 minus 1, that is 3.2 divided by 2. The Poisson's ratio is 1.6. This is your simple problem to find the Poisson's ratio. Next one is types of strain gauge. First one is unbounded strain gauge, bonded strain gauge, bonded metal foil strain gauge, vacuum deposit strain gauge, semiconductor strain gauge, diffused metal strain gauge. So we will study the one by one. First one is unbonded strain gauge. In that the bounding is not available. The diameter of the wire is 0.003 millimeter. The length of wire is 25 millimeter. The resistance of each arc is 120 to 1000 ohm. The input voltage of unbonded strain gauge is required 5 to 10 volt DC supply. This is a cross section of the unbonded strain gauge. This is your diaphragm. This is force rod, strain gauge windings, first and second winding. This is mounting ring. This sapphire post. This is your spring element. This is the spring element. This is your strain gauge windings, third and fourth. Third and fourth is below, and this is your above winding is winding 1 and 2. Again, this is the second. This is force rod. This is support ring. This is housing, sensing housing. This is strain wire having inverted to provide 4 active arc Wheatstone bridge, having their resistances are present. That is like Wheatstone bridge. Insulating post, spring member. This is your electrical feed thought. This is your diaphragm. This is the unbonded strain gauge. Second is bonded wire strain gauge. In that the outer bounding is available. Fine wire with diameter about 0.025 mm. Grid of wire is cemented to the carrier base, to the carrier sheet of the paper, thin sheet of bakelite or Teflon, small as 3 by 3 mm, large as 20 by 25 by 12.5 mm. This is your leads of the papers. This is wire grid. This is a wire grid, felt and paper. This is your bonded wire strain gauge. The materials which is used for the wire strain gauge, that is nichrome. The composition of that is nitro, nickel and chromium. That is your nichrome. The gauge factor is 2 and the resistivity of nichrome material is 100 into 10 raised to minus 8. Second one is constant ton, that is the combination of nickel and copper. Nickel and copper, this is nickel percentage is 45% and and copper percentage is 55%. In nichrome is nickel is 82% and chromium is 20%. The gauge factor of constant ton is 2.1. Resistivity of that constant ton is 48 into 10 raised to minus 8. Isoelastic, the percentage, the composition material is nickel is 36%, chromium is 8%, and magnesium is 0.5%. This is the gauge factor of this isoelastic is 3.6 and resistivity is 105 into 10 raised to minus 8. The the gauge factor of nickel is minus 12.1. The resistivity of nickel is 6.5 into 10 raised to minus 8. Minus 8. Platinum, the gauge factor of platinum is 4.8 and resistivity is 10 into 10 raised to minus 8 ohm meter. Second one is bonded metal foil strain gauge. In that the outer bonding is fixed. The greater heat dissipating capacity, having the greater heat dissipating capacity of strain gauge from a sheet of metal less than 0.005 mm thick by photo etching process. Easy manufacturing process can be applied in curved surface. Can be applied in curved surface. 10 million cycles at plus minus 1500 microstrain can be applied to foil gauge. This is your bonded metal foil strain gauge, which is used for the greater the heat dissipating capacity. The next one is vacuum deposit strain gauge. This is your vacuum deposit strain gauge. Thin film vacuum deposition process to bond strain gauge directly to stainless steel, etc. for the 30 years. The process begins by preparing the surface with remove all surface thin holes and cracks. The next step is the deposition of an oxide layer to insulate and circuit from the metal surface substrate. Following this, a thin film resistive alloy is sputtered over the oxide layer. This film is laser trimmed under power to produce the 4 resistors of the Wheatstone bridge. So, in next lecture, we will see the semiconductor type strain gauge. So, stop here.